Hi everyone, this is Kona, and I'm going to go through the Minitab Anova example question. So first of all, use the Anova _ example data Minitab file to test the following claim and find the correct decision. So the big thing, our data dictionary, this data was collected in a Math 113 class. Students took an online quiz and reported what type of noise was in the background when they took their quiz. The four options were multitask. Students reported there were multiple things going on in the background while they were taking the quiz. TV on. Students reported that the TV was on when they took their quiz. Music on. Students reported that they had music playing in the background when they took their quiz. Or no sound. Students said that they were in a perfectly quiet room. So quiz scores for the students in each group were recorded. Then they were also coded as 1 multitask, 2 TV on, 3 music on, 4 no sound, and the quiz score was just score students got on the quiz. So let's look at the actual data file and talk about this really quick. So the thing here, we've got multitask, TV on, music on, no sound. So you might be looking at these and going, why do we have two different sets here? Basically because this is the exact same set of data, they're just in two different formats. So there's two different ways you can analyze the data using an Anova. You get the same answer, it just depends on how the data was inputted or how you have the data. It doesn't really matter either way, it's just showing you this is what it looks like. So for example, when you go to do, if you had, you were doing an Anova for your project, it's probably going to look more similar to this right here. But you still could do it this way. But the big thing is knowing that this is the same set of data. So you remember environment was coded 1, 2, 3, 4. Well, environment number 1, which is multitask, 60.8 is the score. So here's environment multitask 60.8, then 57.1, 65.0, 65.0, TV on. So that would be 2, 68.3, 2, 68.3. So see how the quiz scores are the same. They're just in one case, we've got them coded going this way, and the other, we've got them in a different column. We still analyze the data the exact same. That's the big thing. We still analyze the data the exact same. I just want you to see the two different ways that we can analyze it. So for now, let's move this over. Okay, so moving on. So our claim. The quiz scores for the students in the group, the quiz scores for the students in the different groups are different. So that's our claim. So step 1, check necessary assumptions. We're just going to assume they're good. Step 2, the original claim is it is the alternative because we're saying that the groups are different, that the quiz scores for the groups are different. And it uses the left, right, both tail. Which tail? It's the right tail. And that's for ANOVAs, we're always using the right tail. So you don't even have to think about it, it's just always right tail if it's an ANOVA. So then use Minitab to analyze the data. All right, so this is where I'll show you how you can do it both ways. So stats, ANOVA, one way. All right, so here response data are in one column for all factor levels. So when it says response data are in one column for all factor levels, that would be this, the C6, C7, environment, and quiz score. So we click here, the response is what's the actual output, what are the actual numbers, and that's the quiz score. The factor is how they were kind of organized, those are the different levels. So in this case, it's environment. Options, yep, we're okay there. Comparisons, we do want to do the Tukey, remember, because if there's something going on, we want to know. So click OK, and click OK. So this shows the interval plot for the TV versus TV environment, confidence interval for the mean. So here's the mean values, and you can see this is for 1, 2, 3, and 4, groups 1, 2, 3, 4. So you can see these are the quiz scores. So the 60.633, 66.9, and these are for the confidence intervals. Now I'm going to minimize that. Here's the Tukey. Don't really need this one, so we can just minimize this. Okay, so scroll up. And okay, null hypothesis, all means are equal. Equal variance is assumed. Here's our different levels. Here's our analysis of variance. Our P is 0, or it's less than 0.0005. Here's our F value. Don't worry about the model summary. We're not going to be messing with that. One thing you will want though, and want to make sure you get in there, is these means for the different groups, the 60.63, the 66.90, the 98.78, and the 85.63. And those are for the 4 different environments. And then we've got the Tukey. And the Tukey didn't do it. All right, I must have forgot to do the stat. Okay, so for this one, make sure I forgot to click a box one way. Under comparisons, we want the tests. Okay. And what that does, it gives you everything is the same except it gives you these p-values. So make sure you click the tests box when you do Tukey because we want that. And why do we want that? Because this p-value is so low. So if we come back to this one. So here's our data analysis, right? So mean multitask, the 60.63, 66.90, 98, 85. You'd want all of those. Our F value 64.86, our P value is 0 or less than 0.005. So that makes a decision that there is enough evidence to support, because remember it's the alternative, the claim that the quiz scores for the students in the different groups are different. What that means is that there is a main effect. There is something going on here, and because there is something going on, so are the group means different or they're not equal? Yes, they're not equal. But we don't know which ones aren't equal. So some of them aren't equal, but maybe some of them are. We don't know. So that's where if yes, then explain. So it's a yes because we've got that low p-value and we're supporting the quiz scores are different. So we are saying they're different. So what we have to do then is actually look at our Tukey. So if it's yes, then that's when you look at the Tukey, and this is the Tukey part that you look at. So which group's variables differ from each other? What you do is you look down this p-value right here, and which p-values are less than 0.05. Any p-value that's less than 0.05 means that the two variables that are listed are different. So basically, what's this showing is that all of these variables are different, except for this one, the 0.163. And if you go across, that's the TV on and multitask. So everything was different. So all of the group's variables differed except for the TV on and multitask. And how do they differ from each other? Multitask was lower than everything except TV on, and we know that by looking. So multitask is lower than everything else except TV on, and we know that there's not a significant difference because this p-value, which is basically showing the t-test value between the two of these, is showing that it's 0.163. So multitask was lower than everything else except TV on. TV on was lower than music on, no sound. And TV was lower than music on and no sound was lower than music on. So, or basically, music on was, different from everything right there too. So, the music on, let's see, where was it? Music on scored the highest. So, I mean, and that's not the only way that you could explain it. You could kind of, basically what you're explaining are the means right here, how the means relate to each other in the groups based on whether or not they were related to each other or not. So what does this mean in real world terms? Students scored the lowest when they were multitasking, but did equally as bad when multitasking as having the TV on. They scored the highest when they had music on. That's just kind of a real world. And you wouldn't, I mean, this isn't the only real world one. You could kind of talk about it in different ways. But so why is this good to do this type of test in Anova versus a t-test? Well, look at our different variables. So multitask, TV on, music on, no sound. If we wanted to compare all of these to each other, these are all of the different t-tests we would have had to do. So we would have had to do 1, 2, 3, 4, 5, 6. We would have had to do 6 t-tests to get this type of information. Or we did one Anova and got information for all of them at once. So this is why it's way better to do the Anova because it does all of these different, what could have been t-tests at once. So we can get all of it. Also because we have less likely to get error or less likely to have error or more error because we're doing it all at once. So you don't get the in-between error as much. So we did this set right here, right? So this is where we did the stat, Anova one way, and we did response data are in one column. Well, what if the response data are in a separate column for each factor level? In that case, you would take these four and add them. Options, that's good. Comparisons, Tukey, make sure we do the test, click OK, and if you notice, here's our Tukey, that's the exact same, and if we come up, here's our analysis of variance. Those are the exact same as when we did it the other way. So this just shows that it doesn't matter which way you do it. Really what matters is how is your data entered, because in general, when you get data, they're not going to be in both formats. I'm just showing you both formats just so you can see this is how you do both of them, but you do get the same answer no matter what. So that's our Minitab example. I hope this helps, and